All right. Hi, everyone. My name is Angad Nanda, and my final project is on self-healing polymers. Specifically, we're using a polyvinyl alcohol and borax hydrogel. In this short presentation, I'm just going to explain what the material is, how they work, and demonstrate a little experiment to show the self-healing behavior. So, self-healing polymers are smart materials that can repair themselves after being damaged. And so this is a growing area of interest in material science because it extends the life of materials and it helps reduce waste. Some of its applications we see are in electronics, biomedical devices, coatings, robotics, all sorts of stuff. So types of self-healing mechanisms. There are a couple different types. Some use microcapsules, which are embedded healing agents that release on upon damage. Others rely on reversible covalent bonds, which reform after breakage. But the one that we're going to look at today is hydrogen bonding, which are reversible physical interaction. And so our project focus for today is a simple hydrogel using just two common ingredients, which is PVA or polyvinyl alcohol, which we're going to be using Elmer's clear glue, and borax, which is a basically used for laundry usually. To self-healing, it self-heals via hydrogen bonding and dynamic crosslinks, and it's going to repair. We're gonna repair it by cutting it and rejoining it together. And so the materials we're using are really cheap and easy to find. You can find them at any grocery store. Elmer's clear glue, which is our polyvinyl alcohol. Um, then we have borax, which is sodium tetraborate. It's a normal laundry booster. And then we're going to use some warm water. A lot of the time people use food coloring in this so that you can, see it better, but I didn't use food coloring in the experiment. So the experimental procedure is I mix the glue with water, and then I add food. I don't add food coloring, sorry. Then I slowly stir in the borax solution into the warm water, and then I put the borax solution with the glue. And so then it creates this gel, which is sort of like a slime. And then we cut it open into two pieces, and then rejoin them back together. Waited a couple minutes, and it self heals. You'll see an experiment at the end, a video of us doing the actual experiment. The visual demonstration I'm gonna put in right over here. All right, so now we're gonna be doing the experiment to make the self-healing polymer. So what we have here is 100 milliliters of Elmer's clear glue, which is mostly polyvinyl alcohol. Then we have 100 milliliters of warm water, which we're going to dissolve 5 grams of a borax solution. So we're just going to dissolve this 5 grams of borax into the warm water. Stir. This is going to produce the borate ion solution, which is going to hydrogen bond. It's gonna make hydrogen bonds with the polyvinyl alcohol. Now, as you can see, it's pretty much all dissolved. There's a little bit left, but that's okay. It should dissolve when we mix it with our glue. So we're just gonna slowly pour this in, little by little. Mix it through. You can see it's already forming a gel. When we add the rest of it, it's gonna harden up to create a proper polymer. Hard enough to keep its shape, yet still self-heal. Add a little bit more. Alright, so all I did here was off camera, I transferred it to a larger mixing container. And so as you can see, we have this hard gel that polymerizes and it stays together almost like a solid, but it's more like a halfway between liquid and solid. So we're gonna take this, just Just gonna set it aside. All right. And now we're just gonna cut it real quick. See if I can grab a knife. What we're gonna do is take a little bit of the slime, cut it in half. All right. There we go. It's in 2 pieces. And what we're gonna do is we're gonna kind of stick them back together, put a little bit of force, just so they have a little bit of more pressure added to them. It needs a little bit of help to heal back together. And now just wait. Wait for it to do its self-healing. Okay, now it's been literally only like 2 minutes. I just did a little bit of cleaning up, and as you can see, it's pretty much fully healed now. You can still see the outside part where I cut it, but the inside stayed together, and even at the bottom you can see there is no cut line. So pretty cool experiment. You can all do it at home. It's just take some simple ingredients, but pretty cool material. When we're trying to explain this on a molecular level, the borate ions interact with the hydroxyl groups on the PVA chains. These interactions are reversible, so when the gel is cut and they're pressed back together, the chains actually relink and cut across the site. Next, we can look at some important applications. The concept is useful in a lot of different applications, such as biomedicine for artificial skin, wound dressing, drug delivery, nanomedicine. In electronics, it's used for stretchable circuits and wearable sensors that can recover from damage. And sometimes they're even used in daily products like phone screens, like your phone screen protectors. There's a lot of them now that self-heal, and they're made of these self-healing polymers. So to conclude, self-healing polymers like PVA borax hydrogel are a great example of how simple materials can demonstrate advanced behavior. Thank you so much for watching.